Hey everyone, this is Miss Fisher, and this is a video to help you with the base conversion lab. So if you take a look at the main method here, we've got a lot of test cases, and when you create a new base conversion instance, you give it two parameters, a string and then an int. So the string is actually going to be a number in base, whatever the second parameter is. Once you instantiate this base conversion object, what you can do is you can call on the reference. In this case, the variable name is test.getNum, and you give it an int, and this is going to be another base. This is a new base. So you're going to convert the current number in base and whatever this second parameter was to a new number in base, in this case 2. Okay. And so then these are the other tests that follow. So if you take a look at the expected output, if you have 10, base 10, then that is equal to 1010 in base 2. If you have AB in base 16, that is equal to 171 in base 10, and so forth. So we know that Java already has methods that will allow us to convert from one base to another. But in this case, within Java, the highest base number you can convert to is base 36. So we actually want to go all the way up to base 62. So we're going to consider lowercase letters different from uppercase letters. So let's go ahead and take a look at the ASCII table here. And if you look at the characters, 0 through 9, we've got the ASCII values of 48 through 57. Then you kind of skip a little bit, and at capital A, uppercase A, it's got the ASCII value of 65. And then you go down to capital Z, which is 90. So that's 26 in our system. That's going to be 26 different digits. But then you're going to have to skip a little bit. And then we've got lowercase a is 97. And then lowercase z is 122. So when we talk about the biggest base that is possible to represent with the 10 digits, 26 lowercase and 26 uppercase, we're going to consider the digits 0, 1, 2 through 9, just representing those quantities. And then after 9, we're going to go ahead and say that uppercase A is going to have the value of 10. B is going to have the value of 11, all the way down to Z, which will have the value of 35. Okay, so if you wanted to, again, go all the way up to base 36, then you would use the 10 digits and then the 26 uppercase letters. But what about if you wanted to, use a base which is bigger than base 36? Okay, so then we would need to start using the lowercase letters. So we're going to assign lowercase a having the value of 36. Lowercase b is going to have the value of 37. And again, these are our chars here. These are all chars. Even the digits are going to be chars. Think of them in the ASCII value, or the ASCII table, all the way down to lowercase z. And that is going to have the value of 61. So if you're allowed to use all 52 letters, upper and lower, and the 10 digits, you can represent and go all the way up to base 62. So if you're wondering, well, why is z equal to 61? Think back to base 10. When you have base 10, you're going to use the digits from 0 to 9, right? Because once you get to the value of 10, then you're going to start over and use two place values, right? The ones and then the tens position. Okay, so z is the biggest digit, the largest digit that has a value of 61 within the base 62 system. All right, so looking back at the Repl.it lab, we're going to take a look at this base conversion class. We've got 3 instance variables, the given number and given base, and then the decval, which is the number given base, basically the corresponding number in base 10. okay, which will be stored as an int. So we're going to use this helper method in order to convert the number in the given base to the corresponding decimal number. Within the constructor, let's go ahead and assign number to n, and we're going to assign given base to b. So decval is going to be assigned the appropriate number, and we're going to call on the helper method in order to help us do that. This is a void method, and this is basically just going to assign decval the proper number, the proper value. I'm going to assign it, or call on convert to base 10. Okay, and notice that we've got a modifier here, and if you take a look at the main method, we call on the constructor to create the baseConversion instance, but then we call on the modifier to test different cases. So this will basically be the same code snippet as a constructor. So I'll just go ahead and copy and paste it down here, and therefore we can just call on set num base, and with the parameters from the formal parameters here, okay, and set num base. Good. So now we're going to work on this helper method called convert to base 10. The first thing you can do is assign decval 0, and then we're going to add to it. So let's look at an example. Let's say we've got the number AB, so this is going to be our number, and suppose that our given base is 16. So if we want to convert it to decval in base 10, base 16, we know that this is going to be 16 to the 0 position, and this is 16 to the 1. So we're going to add to 0, our initial value, the value of A, which we know is 10. So this is going to be 10 times the place value, plus the value of B, which is assigned 11, and then that's going to be multiplied by 16 to the 0. Okay, so that will be 160 plus 11, which is 171. So this will be our decval. Suppose we've got this number, and let's say that this number, and let's say that the given base here is, because we've got a lowercase a, it's base 37. Okay, so again, we're going to think about our place value, and just like any other base system, this would be 37 to the 0, 37 to the 1, 37 to the 2, 37 to the 3. Okay, so you take each of these values and you multiply it by their place value. So this A has a value of 10, that digit. B is 11. A is going to be actually 36, because recall that uppercase Z is 35. So lowercase a is the value right after uppercase Z. Okay, so that would be 36. And of course, 7 is just 7. So this is going to be 10 times 37 to the 3rd. You're going to add it to 11 times 37 squared plus 36 times 37 to the 1st plus 7 times 37 to the 0. And then you would just add those up. So you would iterate through the number either direction, from left to right or right to left, and multiply each digit value by its place value. Okay, in this case it's base 37. Up here it was base 16. Okay, so whatever the given base is. So if we go back to Repl.it, and let's see here. Okay, I'm going to go ahead and just make a decision to go from the ones place all the way to the highest place value. Okay, so I'm going to go ahead and create a local variable called place value and assign it 1. So I'm going to begin with the ones position, and then I'll move towards the left. You could do the other way, but this is just a decision that you can make. And now what we're going to do is iterate through the number, which is a string. Okay, so I'm actually going to start with the last character in number. So that is at length minus 1. And while it's greater than or equal to 0, okay, and then I will decrement my index value. Okay, so now within here, you're going to check for the digit value, right? And we know that the digit is basically the number, the char at the number, okay, at I, okay? And chars are stored as integers, right, under the hood. So you can perform, and they can be part of arithmetic, perform arithmetic calculations. So let's say that if the digit is less than or equal to, now you could look up the ASCII value here. And within the ASCII value, if you look at 9, the integer value is 57. So if it's less than or equal to 57, then you know that it's going to be one of these digits here. Okay, if it's less than or equal to the ASCII value of letter capital Z, 90, then you know it's the uppercase letters. And then if it's less than or equal to, or else, right, that's basically it. It's going to be a lowercase letter. But I want to go ahead and just use the char values because they are actually stored as integers. So char 9 is actually equal to the integer 57. Okay, so you could write it like this, or you could also write it like if digit is less than or equal to, that was 57. Okay, you could do it this way. All right, but either way, I'm just going to use a char 9 so I don't have to keep going back and forth. If this is true, then what does that tell me? That means that, for example, the char value of 0 is 48. So I want the digit, the char 0, to have the in value of 0, right? And then 1 have to have the in value of 1. Currently, we've got 49, 48, and so forth. So you're going to subtract the ASCII value. You're going to subtract 48 from it, okay? Or in other words, the ASCII value of 0, okay? So here we can go ahead and just subtract 48, which is the ASCII value of the char 0. Okay. So next we're going to check if this is not true. We're going to go ahead and check if the digit is less than or equal to uppercase z, because the capital Z's come before the lowercase z's. And if this is true, then digit is going to be digit minus, and then we're going to actually subtract the first uppercase letter, which is A. But that uppercase letter is going to have the value of 10. Okay, so this is the same as checking to see if the digit is less than or equal to, and then if you go here to uppercase Z, that is 90. Okay, so we know that if it's not the digits 0 through 9, if it's less than or equal to 90, then that means it's uppercase. Okay, and then we're going to check if it's not, those are not true, then it's going to be lowercase. So digit is going to get digit, and then minus, and then we're going to subtract lowercase a. And then there are 26 characters, so we're going to add 10 plus 26. So therefore, lowercase a would have the value of 36. Okay, and then lowercase b would have the value of 37, and so forth. Okay, and that should be an else, not an element scanner. There we go. All right, and so once we have the correct value, we're going to go ahead and add it to what's currently in decval. So we're going to multiply that digit value times the place value. And then once we do that, we're going to increase the value of place value by multiplying it by the given base. Okay, so for example, if place value was 1 and it's base 16, we would multiply 1 times 16, then we would be in the 16th position, then we would be in the 16 squared position, 16 to the third, and so forth. All right, and then we are done. This is a void method. This will correctly assign the value to decval. All right, so in the next video, I'll go ahead and explain how to implement getNum. All right, I'll see you in the next video. Bye.